How's it going, everyone? In this video, we'll be taking a look at how to train a machine learning model. We'll touch on subjects such as loss, gradient descent, and what exactly models are. Suppose that I plotted the relationship between the number of hours studied and the grade on the final exam. Now suppose the data looked something like this. What we want to do is we want to find the best fitting line, because the purpose is to use our models to make predictions about new incoming data. And so a model, as far as linear regression goes, is just the function y equals wx plus b. In machine learning, we use w for weight instead of m, which you would use in calculus. And so let's suppose initially our model is equal to 3x plus 1. Suppose we drew it and it looked something like this. Now we're going to characterize loss, and loss is the distance between our prediction and the actual data point. And so if, for example, let's say at this point right here, the number of hours studied was 10 hours, and the grade on the final was 75%. Well, we predicted something much lower than the actual value. And so what you want to do is, for every data point, you're going to draw a line. And so the best fitting line is going to be the line with the smallest red arrows. Or if we summed up all the arrows, it would have the smallest total. And so if I were to, hold on, where's my mouse here? All right. If I were to plot the relationship between the value of w, our weight, which is right here in our function, and the loss, it would look something like this. And the reason why it looks something like this is, for the sake of example, let's say our data looked like this. If w is approaching infinity, it means our slope is approaching infinity. And so our line would look something like this. And you can see the red arrows are much longer than they are in the first case. And in the same way, if my slope were approaching negative infinity, my red arrows would be longer as well. And so the optimal value of W will always be right here at the global minimum. And to determine this value, we use what's called gradient descent. And gradient takes after calculus. In calculus, the gradient always points in the direction of the greatest increase in our function. But here we want to find the global minimum, and so we're going to take the negative gradient. And the gradient is going to have a direction, but it's also going to have a magnitude. And the magnitude, we're going to call that the learning rate. And basically this tells us how big of a step size we should use at each iteration. And so let's suppose that we took the value of W right here, fell somewhere here. Well, we will use gradient descent and we will iterate until we get to our global minimum. And it's important to note that if you took a step size that was too small, well, then it would take forever for your model to learn. And if you took a step size that was too big, you could actually end up overshooting, finding the global minimum. And so after we trained our model, don't know where I am, okay. We would get something like this. And if I drew the red arrows, the sum total would be the smallest possible. And once we have this line, we can use it to make predictions. And so let's say that we were given a student that had studied 20 hours and we wanted to predict his grade on the final exam. Well, we would just take the corresponding grade right here, which let's say is 80%. Thank you for watching. If you have any questions, let me know in the comments.